Okay. Hello and welcome everyone. We're excited to have you join us today for what's set to be an insightful session. It's a pleasure to bring you this webinar and we are glad to feature Mashood, one of our finest engineers. He has been on the team for an extended period of time. Also, we encourage interaction. So if you have any questions, don't hold back. Drop them in the Zoom chat anytime and we will address them during the QA segment. Let's jump right in. I am now passing it over to Masood. We'll get started. Hi, Masood.
Hi, bhai. Thank you. Hello, everyone, and welcome. I am Abdullah Masood, software engineer from AppsCode, working in the KubeDB team. Today, I'll be talking about Qudrant, a vector database, and how KubeDB makes deploying and managing Qudrant on simple, secure, and production ready. So, in this session, I will cover key features of use cases of it.
Can you please share your screen, the slide deck, and then
Okay. In this session, I will cover key features of Qudrant, common use cases, what KubeDB offers for Qudrant, how to provision Qudrant using KubeDB, TLS configuration and a short demo, and finally, the upcoming features. Is designed for efficient similarity search. It is written in Rust, which gives strong guarantees around performance and memory safety. Qudrant supports distributed and highly available deployments, advanced quantization techniques, and to reduce memory usage. So Qudrant is widely used in retrieval augmented generation, RAG, pipelines, AI agents, and autonomous systems. Basically, any system that needs vast similarity search over large embedding can benefit from Qudrant. So why choose Qudrant QD for running Qudrant? Running Qudrant setup for replication, TLS secrets, upgrades, and monitoring. KubeDB simplifies all of this by automating provisioning on Kubernetes, supporting both standalone and distributed modes, providing continuous health checks, which the users can customize, allowing custom configuration, managing secure Kubernetes secrets. KubeDB also ensures communication between replicas, support for production-ready Qudrant versions like 1.15.4 and 1.16.2. This means you can get enterprise-ready security with minimal manual effort. Shows that Qudrant operator on Kubernetes, starting from the user applied Qudrant custom resource at the top, which the operator uses to manage a full set of secrets, PVCs, PDBs, pod disruption budgets, and app bindings. Termination policy controls deletion behavior when CR is removed. Wipeout deletes everything, secrets and PVCs for complete. Reserves both secrets and keeps secrets but deletes PVCs. Do not terminate, blocks deletion entirely to protect production data. For TLS configuration, the user creates Qudrant custom resource and cluster issuer, which the KubeDB Kubernetes services secrets and certificate resources. The cert manager then watches those certificate resources and uses the cluster issuer to provision the actual certificates for securing and deploying services. Let's move on to a short demo where I will install KubeDB, deploy a Qudrant instance, provision in distributed, how to set up TLS. KubeDB with the features for Qudrant using this helm command. As this takes some time, I have already done it. you can see the KubeDB operator pods are up and running. Now I'm going to deploy a Quadrant instance in distributed mode using a Kubernetes custom CR defined in a YAML file. In this YAML, we specify the Quadrant version, the deployment mode. Here it's distributed, the number of replicas, which is set to 3, persistent storage configuration, and deletion policy. Once I apply this manifest, the operator is creating the replica one by one. So first I need to create the namespace. Let's watch the resources. Behind the scenes, the operator ensures that each pod joins the cluster correctly. Health check passes. You can see the replicas are coming up sequentially. And once the initial health checks are complete, the database becomes ready. By default, the Quadrant default operator automatically creates API keys inside a Kubernetes secret. So this auth secret will contain the API. Let's retrieve it. So here is our API key. That there are two types of API keys, read-only access and another is full access. For the rest of the demo, I'll be using the full access API key. Now let's verify the cluster is enabled. So first I need to port forward the service. So here I'm providing the API key as a header, the curl command. So the API key didn't match, so we are getting invalid API key. Let's just change it. So here we can see the cluster status enabled, and there are 3 peers. That means 3 replicas that we wanted. Next, I will create a collection. Here I'm defining the vector size as 5, cosine similarity as the distance made shards to distribute data across nodes, a replication factor of 2 for fault tolerance. So the collection is created. Now I'll insert a point. The collection is now created and we have inserted a point. This collection is now created. So the cluster. So now I'll show how to configure TLS. So let's first delete this resource. First, we'll need to install the cert manager, which helps us manage certificates natively in Kubernetes. So this is the command that will install the cert manager. So as it was already installed, everything is unchanged. Now I will generate a self-signed certificate using OpenSSL. Now I will store the C inside our Kubernetes as a TLS secret. So if we check the secrets, we got the quadrant C. Now we need to create a cert manager issuer. This issuer will be referenced by Quadrant to automatically generate server certificates and client certificates. So if we check, we got the Quadrant C issuer. Now we need to deploy the Quadrant with TLS enabled. In this configuration, TLS is enabled, a cert manager issuer is referenced, client certificate authentication is enforced. The operator will now automatically them into the pod, configure Quadrant to use HTTPS. So the pod is up and running. Let's wait for the database to be ready. So it has become ready. Now let's verify the secure access to. So let's check the secrets. If the secrets that contain the CA certificates and key are generated. So we can here see the TLS client cert and server cert. So if we just check one of them, so we can see the secret has a CA cert, certificate issuer authority, TLS cert, and a TLS key that will be used. So let's first certificate and keys. These have been stored in the local storage. And let's use a curl command to verify. Just first port forward. Here, as both the client TLS and server TLS, mutual TLS is on, we need the client to serve the T. And for the client to verify the certificates of the server, this CS cert will be provided. In Qdrant, we need to make the certificate authority for both the client and server cert the same. So this is used here. And the V flag here is used for verbose. We can see what happens in the TLS request process. As we can see, the TLS handshake happened successfully. So this is how we can configure TLS for Qdrant. Some exciting upcoming features include backup and restore. Backup and restore, monitoring using ops request like scaling and upgrades, and supports for newer versions of Qdrant. That concludes the demo. If you have any questions or would like to any part of the deployment, security, or cluster behavior, I would be happy to discuss.
I guess there is no question at this point. That wraps up our webinars today. Thank you, Masud, for this insightful webinar with hands-on demo. A big thanks to each of you for being here and contributing to the session. We are excited to continue the conversation in our upcoming webinars. Be sure to check appscode.com/webinar to explore our full webinar lineup and secure your spot. Until next time, take care and have a great day. Bye-bye.